In this video, we're going to be looking at another example of a precipitation reaction problem that will require stoichiometry and limiting reactants. So in this question, we are told that 467 milliliters of 1.2 molar beryllium iodide is mixed with 273 milliliters of 2 molar copper 1 sulfate. How much precipitate is formed? Now, the previous two examples were only dealing with limiting reactant, and this question is also a limiting reactants question, even though it's not explicitly said in the question. Okay, let me say that again. This is still a limiting reactants problem. How did I know that? So when I read the question, I see the 467 milliliters and the 1.2 molar, and I also see the 273 milliliters and the 2 molar. Now that is a clue. So when I see data for more than one reactant, I'm like, oh, okay, there's more than one reactant that we've been given the information for. That means that I probably need to figure out which one's going to get used up first based on the information I have. So that means this is a limiting reactants problem. Right, so that's why you got the kind of thoughts you need to be having. We're also asked for how much precipitate is formed. So precipitate, again, that's going to require knowledge of this. Precipitate means a solid. So we want to know how much solid is formed. So all of that tells you this is a limiting reactants and a stoichiometry problem, even though that was not explicitly stated in the question. That's something we can determine by reading the information that's given. So since we know this is a limiting reactants problem, first we know we're going to have to find the number of moles of each reactant. So the moles of beryllium iodide are 0.467 liters times 1.2 moles per liter. If you want to know where those units came from, then check previous videos in the playlist. So 0.467 times 1.2 moles per liter, that's going to give you 0.5604 moles. All right, so that's for the beryllium iodide. And now we want the copper 1 sulfate. So the moles of the copper 1 sulfate, that's going to be 0.273 liters times 2.0 moles per liter. And let's see what that's going to equal. 0.273 times 2, 0.456 moles of the copper 1 sulfate. Now those are really, really close, but again, for the sake of this problem, we can't just assume that we know which one is limiting. We have to prove which one is limiting by performing the stoichiometry. Now in our second step, we're kind of going to get to kill two birds with one stone here, because we can pick the product that has precipitated to do our stoichiometry comparisons so that we can figure out how much of the precipitate was formed. So then again, we're going to move ahead to our step 2. And again, step 2, without having to write it out, we've seen that before. That's just going to be where we compare the number of moles of each reactant to the number of moles that reactant would have produced for a given product, for the same product. So first, we'll assume that the beryllium iodide is limiting. So if we have 0.460 moles of beryllium iodide, we know from the balanced equation, right, because there is a 2 here and a 1 there. We know that 2 moles of the copper 1 iodide, are made for every 1 mole of beryllium iodide. And again, the reason why I set it up like that is so the units of what we already have will cancel out. So this would give us 1.1208 moles of the copper iodide there. So that's how much copper iodide would be made if the beryllium iodide were limiting. Now let's compare for the copper 1 sulfate. So if we have 0.546 moles of the copper 1 sulfate, again, we know same ratio there. There's 2 copper iodides coming out of the reaction for every 1 copper 1 sulfate that goes into the reaction. So that's how we're setting that up there. Doing that specifically so the units of what we don't want will cancel out. And then when you type that in your calculator, we will get 1.092 moles of the copper 1 iodide. So again, we've done our step 2 there. And then I guess what we'll say is step 3 is just look at those 2 numbers, and because we know the limiting reactant is what runs out first, the reactant which produces fewer moles of the chosen product is going to be limiting. So if we compare these 2 numbers, they're pretty close, but it's clear that this one is smaller. That's a lower number, which means that the copper 1 sulfate is the limiting reactant. So this is also kind of setting us up to nearly be done the question, because we want to know how much precipitate is formed. Now we've already been able to determine through our stoichiometry that the copper 1 sulfate will be limiting. Because we know that it's limiting, we know that theoretically it's going to run out first. What we've also been able to determine, that is actually our theoretical yield of the product, of the solid copper 1 iodide. So theoretical yield, when we studied percent yield, theoretical yield relates to stoichiometry, which also relates to limiting reactants, which is part of every chemical reaction. So we know that the theoretical yield of this reaction of copper 1 iodide is going to be 1.092 moles of copper iodide. So we know that, let's just switch to a better color. We know that 1.092 moles of copper iodide is produced. So 1.092 moles. If we're asked for how much, now we can actually pull in a formula that we've already seen before from a previous unit. So in terms of how much precipitate was formed, you could just, depending on the question, it may be appropriate to leave it as moles, but let's just look for the mass, because we can. So if we want to know the mass, we're also going to need to know the molar mass of the copper iodide, which is, I believe it's 190.45 grams per mole. And then we'll just do our, we'll use our formula there to figure that out. So if moles equals mass times molar mass, then mass equals moles times molar mass. So 1.092 moles times 190.45 grams per mole. Again, the units of moles are going to cancel out, and we'll see what that's going to leave us with. So that would be our final answer there. how much precipitate is formed when you mix those two solutions, right? We had to, this question gave you a balanced equation. You might have to predict the products yourself and balance it, which you can do because these are always double displacement reactions, and we practiced balancing lots. And we found the moles of each reactant. We used stoichiometry to figure out which reactant would produce fewer moles of the given copper iodide product, so the same product. We figured out which reactant was limiting, and that gave us our theoretical yield. Then at the end, we have figured out, okay, I know how many moles of the product I made, so how many grams were made, and that's when we can figure out there at the end. We made about 207.9714 grams of copper iodide, which is quite a bit. So that would be a rather large amount of precipitate, but when you think about if you're mixing that much, like you're mixing quite a bit of the solutions with like a decently strong concentration, conceptually that makes sense as well.